Okay, it's the top of the hour, so this would be a good time to get started. Thanks for joining us for our session in the midst of a long series of sessions that are related to various aspects of repository and collections sustainability and replication and continued availability and all the things that are, I think, top of mind for many of us at this particular point in time. Today, in this session, we're going to be focusing on, let me see if I can advance here. There we go. I had to get back in the presentation. In this session, we're actually going to be focusing at a slightly higher level and also with a focus on moving somewhat outside the bounds of individual repositories, addressing some of the issues and seeing examples of strategies for looking at the challenges and opportunities for planning for continuity of availability of collections, even in the face of the dissolution, the cessation of operations for individual repositories. What are some of the strategies that we can potentially adopt as a community for being able to have a higher level of assurance of continuity of discovery, access, and use of the data that typically do exist within specific repositories, but how can we potentially address risks and even identify and develop strategies to manage those risks for continuity of availability. Here we have the link for the SCED page that has a lot of the access points for the materials related to this session, so you can follow the link and the QR code here. Our structure for today is my, as brief as possible, introductory and logistical information. We're going to start with then a set of panel presentations from essentially illustrating different approaches to data replication between and amongst repositories, and some technical examples. Setting the stage first for a conversation about those particular implementations. So we'll have some Q&A for our panelists around what they're presenting. And then we're going to go through a broader exercise where we're going to work in Miro to try to brainstorm and capture additional strategies and implementations, challenges, and trying to prioritize those challenges for replication of data products, and then finish trying to look at how there may be some proposed solutions for that, and using the Miro board as a way to capture and sort of memorialize the input from the ESIP Brain Trust that we always want to try to tap into as a part of our meetings here. So with that, we have presentations from Matt Jones, Dave Viglace, and Matt Biddle. Matt is going to be presenting in person, and Dave and Matthew are presenting virtually. So I think without further ado, I'm going to hand it over to Matt. Oh, and I should also highlight on the logistics slide here, we have the link to the direct link to the shared notes document so that you can contribute to that. And also, please sign in to the shared notes document so that we can potentially track you down and give you credit for your contributions later. And then there's a link here to the Miro board that we'll be using, and we'll have that one up again when it comes time to do the exercise. But if you're wanting to get a head start in getting that loaded up, you can do that as well. And with that, I will now hand it over to Matt, if I can figure out how to get out of the presentation. There we go. So, and there you go.
Thank you. Happy to see everybody today. I'm Matt Jones. I'm the director of Data One and part of the management team. Data One's a large federation of 68 data repositories that currently span all the continents on the Earth. Data One, as a federated data repository, is focused on interoperability, sharing, and preservation of data, and trying to build a network that is stronger together. And we really believe in that mantra that when we can do things together, we really have a much better chance of being able to preserve data, share data, and make it accessible over the long term. So that's been the Data One mission since about 2008 when we started. Today I'm going to focus on a few aspects of Data One that relate to sustainability strategies for the network and thinking about how we preserve data and make it accessible over the long run. I'm going to start with 3 examples of open source software, shared services, and hosting and infrastructure as a service as 3 quick examples of things that we can do as a network, and then dive a little bit more deeply into data replication as a specific service that we offer as part of the network. So if you look at the 68 repositories that are part of Data One, there's a huge variety of different disciplines and domains represented, everything from open topography to oceanography to social science to archaeology. There's a ton of different types of disciplines that are represented in the network. They all have their own software platforms. They all have their own ways of building out infrastructure. But nevertheless, there are a lot of commonalities. And so Data One provides a series of shared services that can be used, like authentication services and other things. But we also find that it's just helpful for groups to work together on smaller platforms. So for example, a number like 15 to 20 of the repositories all use the Metacat system for their repository platform. And another, probably 5 or 6 use the Dataverse platform. And another 5 or 6 use the CCAN platform and the GeoNetwork platform. So having these clusters within the network that are all using the same open source software platforms really can improve the efficiency of operations and maintenance for these different groups. A second place that Data One can really contribute is through shared services. So we've been running a fair evaluation service for metadata that helps people evaluate the effectiveness of their metadata against the FAIR principles for about 5 or 6 years. And we just recently added, in partnership with HydroShare, a new set of services where schema.org metadata that comes from the different repositories can go through the same evaluation service. So HydroShare invested a bunch of time along with some of our Data One staff to extend this system. So now they get these really detailed reports on metadata completeness for schema.org. And the real nice thing about it is that the other 16 schema.org based repositories that are in the Data One network basically get that feature for free. It basically comes as part of being part of the network because one of the nodes really got motivated to provide that. So by working as a network, we really can take advantage of shared services that are helpful across the board. A third area is like providing infrastructure as a service. So Data One has a lot of infrastructure that we've put together in order to operate both the network and individual repositories. And so we can sort of leverage that to help provide repository services for groups that might be smaller and might not want to have an entire IT arm. And so we're running right now 9 hosted repositories where we run the maintenance and operations on our infrastructure and hardware, and they build a community of practice around whatever community they're focused on. So we have, for example, a coral reef project. We have the California Institute for Biodiversity. We have the Ocean Protection Council in California, the Smithsonian institutions using this for their Smithsonian Tropical Research Institute. So these are ways that we can leverage the investment in infrastructure at Data One to help groups really be able to put it together infrastructure without everybody having to do the whole stack. So I want to dive a little bit more into replication. So this fourth area is that Data One as a replication, I think as a network has a real advantage to being able to promote the movement of data across the network. So we already have a shared model of what data and metadata look like through the network. And so individual repositories within the network across the world can make sort of agreements that I want to share my data and replicate it to you. And as a target repository, I might be willing to share and host some data for another repository. So it can kind of flow on this bi-directional basis. This is made possible because Data One has kind of abstracted the data package model in a way that makes it, there's some commonalities across all of the nodes. So all the nodes in the network have data packages where all the objects have individual persistent identifiers for every object in the system. And those objects are linked together into data packages that sort of represent a graph. And so we have a way of communicating about what is in a data set across the entire network of 68 repositories. And then every single one of those objects also is associated with a policy metadata document that allows us to communicate about what we want to do with those. So one of those types of policy blocks that we have is a replication policy. And so the replication policy for Data One objects allows a contributor to specify whether they want a data set replicated or not, how many replicas they want, and which nodes in the network they'd like to see that data set be replicated to. And so every object has these, and then Data One has a service, the replication manager, that goes about trying to make sure that these replication policies are fulfilled. So the way this might work, for example, is if you had a data set at the LTR network node, they might add a CSV file into a data package on their node, and that is synchronized to the Data One metadata service so that we kind of know that it exists. And we'll then, the replication manager at Data One will read the replication policy associated with that new object, and it will then say, make a request to another node, like the Arctic Data Center, and say, would you be willing to replicate this new object that showed up in the system? And the Arctic Data Center gets to decide, yes, no, will I or will I not? And then if they decide to do it, then they make a request directly back to that node for a copy of that data. So you basically transfer the replica data across the network, and then we inform the Data One coordinating node that in fact that replication has been completed. So that the replication manager basically handles moving data around, but the data moves directly from one node to another. And then we have an audit service that goes through and periodically checks every object in the whole system to sort of make sure that all those replication policies have been satisfied. So it's a really nice integrated system. It's generic enough to work with lots of different software infrastructures in the back end, but people have to support the Data One replication API for it to work. Once you've done that replication, then we have other services through the API that allow you, for example, find out what's out there. So if I have an identifier for a particular object, I can call the resolve service in Data One and get a list of all the locations in which a particular object exists in the network. And then that allows me to, for example, build high availability and failover services where if the original node on which an object existed is no longer available, it might be a temporary or a longer term outage, you can retrieve that content from a different node in the network. So I did a quick analysis of like who's using replication in the Data One network, and it's not used as much as I'd hoped. You know, this was, we thought was going to be a really popular and important service. About 10 repositories are the ones that accept most of the replicas. So of our 68 nodes, there aren't that many that are accepting replicas to host for other groups. And of about the 3 million objects that are registered in Data One, about 5% of the data objects and 10% of the metadata objects have replication policies that say, yes, go ahead and replicate me. So it's interesting that it's not being used as much as it would, you know, we'd like. But I think it's still there, and I think maybe in today's environment where people are focusing on data replication, like knowledge that this system exists might make it something that people really want to take more advantage of. So there's a lot of things that we'd like to do to kind of improve you know, the system. I'd love to have a better web display to let people know that these replicas exist for a given data set. We'd like to add some new things to the replication policy that gives people a little more fine-grained control. I'd love to have more data repositories within the network agree to host replicas for other groups. Like that would be a wonderful thing for people to say, I've got some spare storage, let me go ahead and do that. And then we'd love to expand outside the Data One API and let things like schema.org be the mechanism for communicating replication policies and stuff like that, but we don't have conventions for those things yet. So there's lots of work that we could do together on generalizing and making this system better. So these 4 strategies are only a subset of the types of things that we can do at Data One, but I'll come back to say that I think that these types of things are, I think, something that will help us all sort of figure out sustainability strategies as a community of data repositories. If anybody's interested in working with Data One more extensively, please do reach out, and we'd be really interested in chatting with you further. So thank you very much.
Thanks, Matt. And as I mentioned, we're going to have an opportunity to have some Q&A following our third panel presentation. So with that, I will ask Dave to share his screen and provide us with his presentation. Yeah, let's see.
Okay, hopefully it's working now.
We're seeing your presenter mode
Oh,
or your presenter speaker notes information. So you may
oops.
need to share a different screen or window.
That's interesting. Let me try something else. Okay, let's try that one.
That's looking better.
All right, cool. All right. So my name's Dave Viglaeus, and I'm kind of unaffiliated right now, but I work with Matt at NCIS and other groups on various aspects of data management, data replication, and so forth. So today I'm going to focus on a couple of approaches for providing interactive exploration of data collection using entirely static resources. And the emphasis here is going to be on observational physical sample collections. And typically these collections are composed of many small records describing observations or physical samples collected from the natural world. And so usually have like a spatiotemporal component to them. And these observations and samples are often collated into small project or lab repositories or collections that may be integrated with larger domain repositories, but often are not. And all too often, these smaller collections exist for a duration of a project and funds get burned down, and then there's no resources left to host the collection for ongoing access. So as we all know, hosting a repository, even a small one, can be quite an expensive operation, especially when you consider decadal sort of timescales for operation. Obviously, to be sustainable, the expenses for operating a repository need to be covered. And the income can come from a variety of sources, but is often unstable over longer periods as grants come and go. And as we know, even the political climate can have a fairly dramatic impact on sustainability of repositories. So one approach for sustaining operations is to minimize the expenses of operation. So if your costs are zero or low, then it makes it much easier to maintain. So here I'm going to outline a couple of technical approaches where small to moderate sized collections can be hosted at very low and in some cases zero cost. So your typical modern web application architecture looks something like this, where you've got like the browser on the right and the server on the left. And on the server side, we often have an API which interacts with the database through the database engine. And basically every request from the browser or every interaction invokes traffic through the API, the engine, and the database. And this is a really nice pattern, especially for compute-intensive workloads, since you can locate the work close to the data itself. And so it's very efficient in that respect. And this scales by adding resources to the server side. So the more users there are, the more resources are needed to support the application. So basically more CPU, more bandwidth is needed. This means that sustaining this type of application, you need to pay for like the base rate for running your services, as well as account for any demand spikes. And this has been problematic in some cases, especially recently, where traffic from poorly written web crawlers has been consuming massive amounts of resources just to feed AI training systems. And that's been a significant problem in a lot of cases. And cloud providers in particular really like this kind of pattern because it basically guarantees them income with your success, right? So, basically, if you're successful, you're going to be paying for more resources to keep the application running. An alternative approach leverages the emergence of technologies such as WebAssembly modules and data formats such as Apache Parquet. In this architecture, the application runs entirely within the browser, only retrieving small portions of the dataset needed to support the actions and rendering in the browser application. And this pattern is highly scalable because all the work is done within the browser itself. With more users, there is more traffic to the server, but there's no additional compute or related expenses on the server side, since all the work is done in the browser. An important feature of this type of architecture is that the application and the data can be hosted entirely from simple static web servers, and quite often within the free tier of resources available from providers such as GitHub, Dropbox, Google Drive, Cloudflare, and so forth. There's a bunch of opportunities for free hosting of moderate-sized systems. This approach is, however, limited to static collections. So this is really like end of life for things that you want to archive. But you can also work with periodic snapshots of collections as well if you want to expose like intermediate results. So as an example, here we have a static snapshot of about 11 million physical sample records from the Smithsonian Institution. The content is being served purely from a single static GeoParquet file and rendered in a Quarto web page. As the user clicks on individual points, a spatial query is handled by a database engine running entirely within the browser. And the subset of records matching the coordinates of the click location are retrieved from the server and rendered. And of course, identifiers for the source records enable click-through to the original content that's actually hosted at the Smithsonian. So this is just an example of the kind of spatial, a simple spatial search within that context. Another example, the index to marine and lacustrine geological samples suffered a fate of rapid decommission in May this year. With support from Kirsten Leonard at Columbia University, a snapshot of the data was taken, converted to GeoParquet, and we've been exploring some implementation of temporary read-only interface to those data to provide ongoing access. The app demonstrates text search within the 230,000 or so records represented by dots on the map. That query identified records where a dredge was used for sampling. You can see it's fairly responsive. As you enter the text and do the query, the SQL engine within the browser figures out what pieces of the Parquet file to retrieve, returns them, and renders them in the browser. This is clearly a prototype with plenty of aspects to clean up, but it's basically a proof of concept that this seems to be a viable approach for this scale of data collection. This application is hosted entirely for free using GitHub pages, and the server is being served from a Minio server that's on a very low cost service. And it could easily be replicated to another file server or another repository such as Data1 or Zenodo and so forth. So this is all based on two pieces of technology, primarily Apache Parquet. It offers a convenient way to package the sample records, and the records themselves can be quite structured. And combined with tools like DuckDB, running as a WebAssembly module in the browser, it provides a really efficient mechanism to exploring even fairly large resources and supports common query and subsetting operations including text search, spatial search, numeric, and faceting operations. There are, of course, some significant limitations. The content is static, and you're limited to what's available in an individual web browser. But you can do surprisingly quite a bit just within the context of a web browser when you don't have to retrieve the entire data set into your context that you're working with. But beyond that, there's some challenges. So, for example, how do you elevate the discoverability of such resources? How do you handle resolution of identifiers that point to individual records within the Parquet file? Because you can pull Parquet file, but pointing to the internal of the Parquet file You need some service to support that. And what about things like access logging and usage reporting and so forth? All those require interaction with some other services, such as, for example, other data repositories. So I think there's a really interesting opportunity for support of this type of data collection emerging from lab or project-based collections, which can be moderately large, and they're looking for a place to live. With this Parquet file format, you can embed the metadata about the content directly there, and of course, all the data associated with the records. Basically, I think there's an interesting opportunity for, with some slight changes to existing repository infrastructure, I think they'll be well suited to supporting this type of approach. Basically, what needs to happen is that servers need to support byte range requests, and the vast majority of them do already. That comes automatically. There needs to be some support for individual identifier resolution for individual records. I've mocked up some prototypes for that, and it's actually fairly straightforward to do. And this would enable continuation of things like IGSN or DOIs or ARCs pointing to individual record samples being able to be presented as like landing pages by the hosting repository. Then things like access logging and reporting. It'd be great if there's consistent implementation across repositories, so you could do like aggregated access reporting using protocols such as make data count and so forth. So basically overall, I think the static data resources alone provide a powerful tool for working with snapshots or collections of archives, but they can really benefit tremendously from preservation and sustainable repositories that implement some of these minor adjustments to provide operational consistency across those repositories. And there's some references at the end there for those that are interested in the technology. Thank you.
Great. Thanks, Dave. And we'll now finish our panel segment with our presentation from Matt Biddle. The Matt's show continues.
I prefer to go with Matt squared, if that's okay with you. Awesome. Are we good to go? Can you see my screen and hear me all right?
We are good to go.
Okay. There we go. We're good. Cool. Thank you so much for inviting me to talk. I just want to give a big shout out to Carl for being in person and coordinating it, and to everybody for coordinating this session, and to Dave and Matt to team me up perfectly to talk a little bit about ERDAP and what role it could potentially serve in data replication and repository succession. So hi, my name is Matthew Biddle. I am with NOAA's Integrated Ocean Observing System Office. I have a lot of different roles. One of them is the co-chair for the ERDAP Strategic Insight Group, where we do presentations like this to talk about ERDAP and where it can fill different roles in our data management community. So what I'm going to talk about today is a little background about ERDAP, some overview of the different people that are using it, why we should use it, and where it's going in the future. On the right-hand side is the really ugly front page of ERDAP. Yes, it's ugly. We know that, but we don't care. We're moving on. So what is ERDAP? ERDAP is an application that you can install. It's a data broker or a data server, and it's designed to deliver data and metadata easily from any data source into the user's favorite client software or format. So the idea is to help people take data from whatever format it is that they're using and provide it open and accessible in fair formats or in whatever format it is that the user might need, because we all know everybody uses different formats, and ERDAP is there to help us meet those different user needs. It was initially developed by Bob Simons. He retired in October 2022, but he was at NOAA Southwest Fisheries Science Center in the Environmental Research Division. The ERD is part of ERDAP, but it's not an acronym anymore. So we're going to just pretend like it was never an acronym. But Bob retired, and Chris John actually stepped in from NOAA Southwest Fisheries Science Center to serve as ERDAP technical director. So he sat in with Bob for a couple months, learned all the back end, all the good stuff about Java, and actually is the new technical director for ERDAP. So he's developing and continually moving ERDAP into the future. So this is a really valuable tool for for aligning data with the FAIR principles. And we've been really hard in pushing it into the open source community. It's always been open source, but we're really pushing to have the community contributing online and everything. So we've moved a lot of documentation, a lot of the development into that erdap.github.io. If you go there, you will find all sorts of really useful information. So how does it work? There are some requirements. You can install it on your local system if you know Tomcat and Java and all the crazy stuff. I don't. That stuff blows my mind. It doesn't make sense to me. So I use Docker. They have a Docker container where it spins up all of that stuff for you. And we have a quick start that we've written up in iuse.github. Where you can spin up a Docker container running an ERDAP within like 5 or 10 minutes. And I've done it before, so I am a testament for the novice person who isn't a computer scientist to being able to spin up an ERDAP relatively quickly just with installing a couple applications. The whole system runs on mainly on this datasets.xml. It's an XML file that describes all of the datasets in the ERDAP, how to read them, how to add in metadata, make virtual datasets, all sorts of different stuff. So that's kind of the brains behind ERDAP and how it works. So who's using it? Most of the line offices within NOAA, a couple different other US agencies, and 160 organizations across 20 countries. That's a pretty big swath of folks that are using it. There's a really good resource, the awesome ERDAP GitHub repo that the Irish Marine Institute hosts. There's a list of all the ERDAPs that are out there and all their URLs. So if you ever want to go search for all the ERDAPs, you can go there and there's a really comprehensive list to be able to search. So there's a lot of organizations, a lot of people using ERDAP to share their data. So in alignment with FAIR, I think most of us know all this stuff, but it can easily augment metadata to make our data more findable. It generates ISO metadata, so we're meeting some of our NOAA requirements and other federal requirements. It also supports schema.org metadata. There is some exploration right now into Coruscant. I don't know what that means, but it's something with schema.org and AIML stuff. I don't know, but it's we're getting more into the findable space. It provides access to the data in a variety of formats, supports RESTful services, machine-to-machine access. It also provides a platform where data-specific applications can be built, kind of like what Dave was talking about previously. All of this leads to improved interoperability, and it supports the creation of Baggett packages for long-term archival, so you get metadata, or you get checksums and all of those things to verify data transfer. And it supports climate and forecast metadata, as well as JSON LD. ERDAP does not capture data in a proprietary database or a file format. It reads from what's called these classes, all these different Java classes, and you'll notice some of them are database classes, some of them are ASCII files, some of them are CSV files. It basically reads from a whole bunch of crazy different formats, and it makes them available in a whole bunch of standardized output formats. So if you want data in TSV, you can get something that was a netCDF in a TSV file. If you want something in Parquet, you can get it from a netCDF and make it accessible via ERDAP in Parquet. We are working on MQTT. I don't know what that means, but it provides another access mechanism to read from and as well as provide access to. So on to the replication piece. ERDAP has the capability to federate from other ERDAPs. So it has one of those classes that I mentioned earlier, this EDD table from ERDAP allows you to actually take an ERDAP and read from another ERDAP. So we get ERDAPs of ERDAPs of ERDAPs. The one that I have linked in there, that ERDAP actually has nothing residing on the machine where the ERDAP is hosted. What it does is it links off to all of those individual ERDAPs, but it provides one aggregated source. So we can have, as what's depicted in this diagram, multiple ERDAPs hosted at different places, and you have one that connects them all together and provides all of these consistent output formats. That's really nice, but what it does is it basically diverts the requests to those source ERDAPs. It isn't actually doing the requests within that federated one. So there's other ways that ERDAP can facilitate this remote replication of data sets. I should say Bob Simons went on a crazy tangent in his documentation. If you want to read it, I linked it there in the bottom. There's a whole bunch of really good information. One of the quotes that I pulled out there is, a data provider maintains a data set that changes occasionally, and a user wants to maintain an up-to-date local copy of the data set. There's a huge number of variations to this, and I've listed a couple of them there. There's a custom brute force solutions. Write some Python script that'll go out and rip data down and pull it into your local system. Use rsync to keep it in sync with whatever's out there. ERDAP has a couple tools built in to facilitate this, such as cache from URL, where it'll actually go out and grab a file off the internet and download it to your local system. It also has the EDD table from ERDAP, and that's that federated ERDAP approach, where we have a link to another ERDAP and it's pointing to that other source. And then there's also EDD table copy, where you can point to another ERDAP and say, hey, go get me the data from that ERDAP and download it to my local system and provide access within my system, so that if something were to happen to that other system, I have it on my local and we can provide access there. Again, there's all sorts of documentation, and I have a website that I've been writing up for the demonstration that we're gonna, oh, this was supposed to be really cool. There's a splash, but it didn't work. Later on today, we're gonna do the hands-on session for how to replicate data across similar systems. I am going to walk through how to do this for 1 or 2 data sets. So I'm gonna walk through each of those examples. If you're interested, please come. It's at 4:00 p.m. I have no clue what time it is Eastern, but I'll be there. And I'll be tired. ERDAP does have cloud capability. It can work with files in AWS S3 buckets directly, and it uses that cache from URL. It goes out, it grabs the data from the bucket, pulls it into your local system. And it's also designed to run with Tomcat, which can be run locally or in cloud environments. So when you get the question of, is ERDAP cloud capable? Well, yeah, you can put it up on a cloud system. You can access cloud data. It all depends on what you mean by that question. Again, if you have questions about the cloud piece, there's documentation in there, and there's quite a good explanation of all the caveats and known considerations. I'm not sure where my timing is. I'm probably getting pretty narrow, but the other capabilities within ERDAP is you can aggregate data files. So if you have a whole bunch, this is an example of, I got a whole bunch of CSV files on my local system. I'm going to point ERDAP to a directory. I'm going to say, look for this regular expression of files, and then I'm going to make that accessible as one table. So I have, I don't know how many files here, a whole bunch, but I make them accessible as one data set on ERDAP, and the user is none the wiser of what's going on in the back end. We can also derive variables from our source files. So again, I have that same example of a whole bunch of files. I set an equation that says, take the file name, extract out the year_month, and convert that to a time. And then we see on the right-hand side where we're actually making that time variable. So the user has no idea what's going on in the back end, but what I'm doing is I'm taking the file names and I'm making a time variable so that it's more interoperable and more reusable. The metadata tools, I've already talked about schema.org. It provides JSON LD right out of the box. And it also, the Coruscant schema is under development, and that's through Google Summer of Code. There is a script that helps you generate datasets XML, which is that brains of ERDAP. That it's super helpful. I highly recommend using it, and it automatically generates the ISO metadata. One of the really great things about ERDAP is the consistent access. If you know how the URL is structured, you can build applications on top of that and do whatever you want, because there is this consistent URL structure. There is some capability to be able to actually put data into an ERDAP from an outside user. So this table from HTTP GET, if you give someone permission, they can actually put data onto your ERDAP server and write into your system. There's also the capability to archive a data set. What this does is it creates a Library of Congress package, which includes manifest checksum information. So if you do need to transfer data around, you can actually check that the checksums do match and you're actually getting the correct information transferred between systems. And then there's some conversion tools, some other tools about being able to interpolate onto a gridded file, some authentication. You can log in with Google or ORCID to be able to restrict access to data. And then there's all sorts of community built tools on top of it. We are working on a strategic insight group to identify the path forward for ERDAP and ensuring that it has continued support. And we're doing that through Google Summer of Code. We have a whole bunch of projects, and we just got 2 more accepted this year, and they're moving forward on the MQTT and then updating the rendering framework. And I think that's it. I hope I didn't go too far over.
Excellent. Thank you, Matt. So this is now a time when we can field any questions for our panelists about what they've been talking about, and then we'll segue into sort of a group exercise. So questions?
This is a question for Matt. I know you had to gloss over it at the end, but I saw authentication and authorization pass by. Can you elucidate where you're going with supporting that form of interfacing through that? Thank you.
Yeah, so great question. It already supports it. So in your configuration, when you're setting up the ERDAP, you can authenticate with Google. You can authenticate with what is that, OrchID, to be able to, I guess, limit access to specific data sets. So that is already part of the system right now.
This is a question for Matt Biddle as well. This is Ian Nesbitt at Data One. I'm wondering if there is a way to generate a sitemap of all of the data sets that are in an ERDAP. I know you mentioned that there's schema.org metadata associated with each data set, but is there a way to find that in a centralized location? Because that's important for us to be able to scrape that metadata if that's available.
Yeah, that's a great question. So there is a web accessible folder that ERDAP provides, and you can make it, you can link, actually just wanted, can I share my screen real quick so I can show? So there is a web accessible folder for the FGDC records. There's also a web accessible folder for the ISO records. And then there is a files data set, which is kind of that sitemap that you were looking for. So there's various different points at which you can get to those files.
Yep.
Hey, this is Chris Lonhart from NCAR. A question from Matt Jones, the other Matt. Really cool about Data One and all the diversity, of the different repos. And I'm just wondering how you navigate the sort of general versus specific, if there's requirements or, vocabularies, that kind of stuff, if you have to deal with that much.
Yeah, as a network, Data One deals with all these different disciplines, and they each have their own disciplinary metadata standards and other things, and we basically accept that. We have an embrace sort of mentality, and so we support, I think 15 or 20 major metadata standards, and what we do is we built a harmonization layer on top of that will extract metadata out of all of those different domain standards and creates a common search interface, but we maintain each of the individual domain-specific records and can redeliver those to whoever asks for them. So we kind of like do a both and then we have a bunch of semantic sort of alignment layered on top of that. So we have a semantic annotation system that lets people draw terms from different domain vocabularies and attach them to their records, and then that becomes part of the Data One search system. So yeah, I would say the heterogeneity is not going away, and we have had that sort of like strategy that we need to embrace it and accept that it will continue to evolve both within and across disciplines.
Yes.
I'm Kelsey Hulsman. I'm the ESIP support for this session, but also a scientist with questions. My question's for you, Matt Jones, you were sort of talking about encouraging any of those 68 different groups that are within Data One to host others' data. Is there sort of a way to do that in an efficient way that also sort of has that safety idea of like preserving data where it's like it's in, you know, 3 different places where they're all sort of, you know, prone to different kinds of risks? And is there a way currently for any of those groups to say, hey, I have space? Is it a requirement for Data One to say how much space people have? Could it be a requirement that you have to host another group or two's data in general? I'm just curious if there are any, you know, ideas to kind of encourage that data replication.
Yeah, thanks. That's a great question. I think it's building a consortium like Data One is a little bit of like convincing to people to do things that are a little outside of their wheelhouse, you know, that might not be immediately part of what they're trying to accomplish, but they do want to connect. So we have acknowledged again that there's different reasons people join. Most people join to just promote the sort of discoverability and availability of their records. A smaller subset have like the idea that they want to participate in order to build out a preservation network. I think those groups are fairly easy to convince to become replication target nodes. There are a lot of nodes joining today that are just using schema.org as their primary means of advertising, and they don't really have a storage system that allows them to take arbitrary objects from other groups and store them and like parse and manage the metadata. So I think some platforms are more amenable to this model. So like the 3 I mentioned, so Metacat, Dataverse, and CCAN, all work really well with this. They're all general purpose data repositories that aren't particularly tied to domain, and you can put any kind of data in there, and they all support multiple different metadata standards. So those can be adapted to work as Data One target nodes pretty readily. Other people have really domain-specific data systems that might only take one type of vegetation data or one type of, you know, biodiversity record or some other like specific thing. And so those are harder to push an oceanographic record into a soil science database or something, right? So I think it does vary based a little bit on the mission of the organizations. There are enough general purpose repositories in that list of 68 that I think I'd love to get 30 or 40 of them, you know, offering replication space, but yeah. I don't know how to get there exactly, but.
This is Joseph, one of the organizers. So I'm throwing out a loaded question. What would it take for ERDAP to become part of, say, the Data One consortium? Are there any nodes in Data One that are running ERDAP right now?
There are nodes in Data One that are running ERDAP, but we aren't using ERDAP as the mechanism to harvest from them. So like the Alaska Observing, the AOS node runs an ERDAP server, but also is part of Data One, the research workspace up in Alaska. There's a variety of places like that. I think it would be pretty straightforward based on what Matt described for us to harvest schema.org metadata from an ERDAP node. I think Ian's question was exactly that. It was loaded like, you know, how can we make this work more efficiently? So we just need to talk about it. I've had a number of conversations with James Gallagher as well about using OpenDAP servers more generally and thread servers as there's no barriers there to doing it. We just have to spend some time connecting these systems. Yep. Yeah. I don't know what you think, Matt, but that doesn't seem like a huge lift to me.
Yeah, I agree 100%. So with one of the things that we do within iUse is we host a data catalog, and what it does is it harvests those ISO metadata records from ERDAP and presents them in our data catalog to go on to data.gov and all of those other things. We've also, there's been conversations about getting the schema.org metadata available to ODIS, the Ocean Data Information System. So I think there's similar conversations going on in multiple realms around this similar vein. So it would be interesting to pursue it a little further.
Other questions?
This is a question largely for Dave. I like the presentation in terms of showing sort of an extreme of where we could actually go towards something more sustainable. I wanted to get maybe some confirmation that you would consider a sustainable repository to be much less server-side compute and service-oriented, but instead push effectively those codes and services to the client and have them empowered to do the processing there. Is that kind of the trend that you think might be a more sustainable route for repositories to go?
Yes and no. So it really depends on the type of resource you're working with. In some cases, like large hyperspectral data sets, for example, you're stuck with working with those primarily on the server side just because of the nature of the data. There are tools for working client side, but very limited capabilities. But other types of resources, there's no reason why we can't push a lot of that work to the client side. I think the main point, though, is that repositories need to be able to, at the technical level, support the requirements of being able to serve this content in the browser space, because the way things are going, I believe there's going to be more and more reliance on the browser itself as the engine for interacting with the resources. And even now with things like DuckDB and so forth, you can do like joins across different Parquet files served from completely different repositories, all happening within the browser. So it's a very powerful technology that's still very emergent. But I think there's also a great opportunity for some harmonization in the services and functionality that are provided by repositories to support this type of operation. Of course, it will lead to greater sustainability because it's going to reduce the load on the servers themselves.
Matt? Yeah.
Yeah, Dave, can I follow up with that? So your talk was great. As you know, I think it's a fantastic architectural approach. You focused on the client side browser access for UIs, but can you talk a little bit about the way that, you could use a server as a client as well? And that, if you wanted to say do big data processing with this same model, cloud-based access is still reasonable, right? Like even if you're not using a browser, you could use, say, DuckDB on the server side to implement a much more complicated and potentially large-scale application, right?
Oh yeah, absolutely. And in fact, I didn't mention this, but the resources that are showing available in the browser, you can load them up into like QGIS on your desktop, for example, and there's no reason that other repositories couldn't interact in the same way with those resources to do really interesting like graph operations across these distributed resources. Sure.
Yep.
Other questions? I have one that may sort of cross all three implementations and examples that we've seen, and it comes back to sort of the intersection of repository sustainability and collection sustainability in terms of the potential of preservation as a service. As you mentioned, the infrastructure as a service, the hosted repositories model, the individual implementations and hosting of AirDAP, the lightweight access model for the static files. Is there potentially an opportunity for preservation as a service that can provide, at the very least, that sort of foundational capacity for continuity of access of collections that's potentially more lightweight than the full service stack that individual repositories may provide for their collections, but do provide that backup capacity for the continuity of the collection itself? Is that something that you see as a potential space for covering the real costs? This doesn't come for free. As a way, but maybe it's something that could be done at scale so that the costs are more manageable. Thoughts?
Yeah, I mean, I think that implication of a service is that it's somewhat centralized, but I think if you got away from that, then it could work. Like, so if you're thinking about preservation as how can we as a community, set up some standards for how people can replicate content to multiple different geographical locations and administrative and financial domains so that the probability of them surviving goes way up, then I think these kinds of architectures can help. Whether that's doing something through the Data One or through ERDAP, or like Dave said, building these sort of lightweight content-based cache dumps that are accessible to lots of applications, all of those strategies can be used as part of a service strategy to basically make sure we have lots of the copies. I think the biggest challenge to preservation right now for us is not the technical approach we take. It's really about the correlated risk of all of the different groups that are focusing on this all losing funding at the same time, right? So it's the correlation that's the problem, right? And trying to figure out how to hedge against that is really about figuring out how to get as many groups as possible invested in part of their role being providing preservation services, not just one centralized group, right?
Yeah, I'll just add to that a little bit. And on the functional capability side, one thing we need to be very aware of course, is we're relying on persistent identifiers to point to different resources. And for individual data sets, that's not too terrible to work with. I mean, you move a copy somewhere else and you update the the data site reference to point to the appropriate location. But one of the challenges I've been working with is dealing with a situation where you have like multiple, in some cases, millions of records in a collection, each with their own DOI or ARC identifier, that are then bundled into this single resource that also needs to be resolvable down to the individual entity level. And I think there's some capabilities that could be offered by existing and emerging data repositories that would facilitate this, so that as copies of collections are made around the place, there's essentially an automatic update to the resolver services, so that resolution of those identifiers continues to function as expected.
Matt?
Yeah, I would just agree with everything being said. The one tool that I do know that would facilitate this is, like I mentioned, built into ERDAP, but it is a standalone tool called Baggett. Not only identifiers, but also checksums of files. When we're moving stuff around, we need to make sure we're actually getting the right file. So I'm putting my NCEI archive hat on, that we need to have those SHA-256, MD5 checksums sitting next to the data files so that everybody knows that what copy or what version of the data they have. And we have some integrity checks to make sure that everything moved as expected. So that's my only comment.
And Matt, I wanted to mention that one of the Data One APIs that we've tried to standardize on is a get package API that delivers just what you're talking about. Baggett is one of the package formats that the network wants all the repositories to support. So, yeah.
And Data One also provides checksums for all the content as well, which is pretty handy.
So unless there are any more questions, this may be a good time to transition into our group activity. Let me see if I can go back to the browser, if I can navigate this. Oh. Okay. I'm going to turn this off. And where's my Zoom? Oh.
You see you see how it's showing YouTube? Yeah, there you go.
That's the one. I can go to share screen. And share our entire screen. Okay, I think we're now successfully sharing again. And okay, excellent. So we're now at the point where we were going to, let's go down. We've done our panel presentations, we've done our Q&A. Now we're ready for our shared activity in the Miro board. So let me present this. This is the link to the Miro board. So you can open it up on your own device, or you can access the presentation in the shared drive. And the goal here is to start out with working in, and this seemed to be a model that actually worked fairly well in another session that I was in, working in small groups or individually. It's a good opportunity to interact with your neighbor or neighbors. Let me bring up the Miro board. See if it'll let me.
It's in the notes document as well.
Okay. See if it'll let me open it now. Okay. It slowly loads up. I see people in there. That's a great sign. And what I was hoping we could start with is working in, like, as I said, individually or in small groups, to just start out by identifying some challenges and risks and adding them to this quad chart that basically has some pre-positioned Post-it notes, and you can make copies of those Post-it notes to go beyond the ones that are already in the different quads, where the risks that are that you can provide, if you can position them basically in the quad chart from, maybe they're long-term risks, or they are immediate in terms of the time frame that we're potentially talking about. And that's our left to right axis. And then from bottom to top, those being potentially low risk in terms of the risk to the continued access and usability of particular data products, to essentially existential, where they are gone and really gone. And the potential magnitude of that loss in terms of risk. So let's just take, it's a little after noon right now. Let's just take about maybe 10 minutes to work amongst ourselves. Like I said, this could be a good small group exercise, and you can collaboratively add some Post-it notes. We're going to follow this up by an opportunity to look at what's been provided and adding some little priority voting stickers to those that we as a collective can try to float to the surface in terms of high priority potential areas for action and activities. And then we can go from there to closing out the session with suggestions for how we might be able to step forward, continue moving forward with trying to actually address some of the high priority issues. So let's take 5 or 8 minutes, and then we'll go through the prioritization process. Yes, Matt?
Could you just clarify the axes? Like, they both kind of say risk on the two things. Like, which one is one of them like the severity of the risk, and one of them is the timing of the risk?
The severity is the vertical axis. The y-axis is the severity. The x-axis, the horizontal axis is time.
It's labeled severity of risk over on the right. That's correct.
It was edited after I. So yeah, I think probably the orientation of the labels is throwing things off. So yes, it may be easier to look at the labels on the arrows themselves, at the endpoints on the labels to better understand. Too many labels.
You want us to work in small groups?
If you work individually or in small groups, whatever you're most comfortable with.
Hey, Carl?
Yes.
I just had a quick question. I'm having a little trouble figuring out scope of what we're trying to put on the sheet. Are we talking about services? Are we talking about data sets? Are we talking about agencies? There's a lot of different ways I could interpret what I'm trying to put on the chart.
Yeah, at the bottom line, it's the data sets, but then there could be an additional layer on top of that in terms of services based upon those data sets. But and this is probably just a bias that I come into this with, I tend to separate the data sets and the services a little bit in terms of one being necessary for the other, but also them having slightly different different things to consider.
Okay, that
But
helps. Thank you.
Yeah, the agencies are, I would also bring in repositories. That's probably a part of how the risk is defined, but the focus is on the risk to the collections or the services.
That's like the third axis.
Yeah. The likelihood of risk is it is a third dimension.
Right.
And
There's some things that I'm thinking of that are really super high risk, but they're not
right, and this is where potentially the follow-on prioritization might come in, because that's trying to do a three-dimensional Miro board as right. Yeah. Yeah. And that's also where there's a circumstantial or domain or user-specific variable as well in terms of the importance. The impact is variable to different users. Mm-hmm.
Right, yeah.
I still see some things moving around. Maybe we'll wait, we'll work on it for another couple minutes, then we'll do a quick brain dump. So maybe if you've provided some, you might think about if there's anything you'd like to share with the group around what your challenges are, if you want to share more broadly before we go into a prioritization exercise. Okay, things may be slowing down, and maybe it's that now we have two copies of the the item layered on top of each other. We'll just focus on the one in front. So as you were going through this exercise, what are some of the highlights that came to you, either in what you were suggesting, or as you look at the board, some things that caught your eye in terms of what we may want to focus on going down the road? Anyone have something they want to share? Or have you left it all on the board? Yeah.
So I put a software rot, lack of maintenance, and I saw a couple other tags like sort of in that line of how difficult it is to maintain software, maintain legacy software. There's something in there about legacy software interacting with new pieces, you know, basically trying to keep things up to date. That's like the perennial problem in development. And so I put it in the sort of like middle of the road in terms of whether it's an existential crisis or not, and in the long-term section. But yeah, it's something that we all always have to think about.
Yeah, and I think that is particularly relevant as we perhaps try. I know this has been the case for me, is trying to wean myself from I must build it here because I want all of my priorities met, instead of looking at adopting an existing, supported, and maintained solution. Others who want to share what they might be seeing in certain terms of some emerging patterns or the items that you added? Yes.
This was Matt Jones's idea mostly, which is this is a big existential threat, but probably farther off in the future. But I thought it was worth mentioning is sort of, and I think it aligns with the idea of almost like community support is good, but not enough. So there's a massive financial burden for some of these things, like NASA's huge entire collection of data has a multi-million-dollar annual budget. I don't know if that's accurate, but it's a bigger thing to tackle than what citizen science could do. There have been all these efforts which have been really wonderful to try to save data as they seem to come under threat by, groups of people, groups of scientists, not necessarily in sort of a well-funded institution. So that's certainly something to figure out. It might not be immediate, but it is a big existential threat, how to preserve those data. Did I summarize that well enough?
Yeah, I think that's an excellent point, and that relates to the metaphor I've often found myself using, as there seems to have been a trend towards increasing reliance upon contributed effort or community support in the absence of direct support. And for me, it's been sort of, the metaphor has been asking all of your folks that are doing their work to stand in a circle and reach into the pocket of the person next to them to pull out whatever it is that they need. But that circle is getting smaller and the pockets are getting more empty. And that model is, I think, decreasingly effective when we still have to address real costs. Any other ideas or observation? Chris, you look like you're queuing up.
So I just want to throw out something that, at first I put it on there and it was more like a positive risk, but the more I thought about it, it's like, well, okay, it is potentially a risk because you can't respond. And the issue, or what I put out, was event-driven kinds of things. So, COVID being one is a thing that both spurred data sharing, but also created challenges, responding to natural disasters, things like that. So my original purpose was to put something out there, was kind of flipping the script a little bit, but it also becomes a driver. Both can you respond, but also can it be an opportunity to respond? So.
And I think that may relate to what Denise and I were talking a little bit about during the exercise and probably the reason why I added the timing dimension to this, as that seems to be top of mind in terms of we've maybe been sensitized most recently to the not having the time for planning and execution that we have historically assumed. And so that was one of the reasons why I included that. But Denise also highlighted, a third dimension that we don't have in here, which is sort of the magnitude or the likelihood that are also, other dimensions that are commonly used when trying to assess risk and develop strategies around mitigating risk. Yeah, I think we've been able to capture a lot of useful input here, and I haven't even had a chance to even try to start digesting it. But what I would recommend, we've got about 10 minutes left in the session. What I would ask at this point is maybe if we take just a few minutes to take a look at what's been suggested, and just above the Miro board, there's a little palette of dots, of colored dots. And I wasn't able to figure out a way to get Miro to let me customize them in a way that was going to be less, perhaps, unfriendly to those who may have color vision issues. But as a way to, as each of us have potentially contributed one or more ideas, but as a way to look at the ideas that have been suggested and identifying those that would be a low, medium, or high priority based on essentially voting with some of the dots. So what I would ask is that, maybe go ahead and choose, and you should be able to click on the individual dots and drag them to where you'd like. And drop them. What was that, Mark? In terms of what we should potentially focus our attention on, where we should focus our attention in terms of developing strategies to mitigate these risks. And in some cases, the traditional view might be that items in the top right quadrant are often those that reflexively fall into a higher priority, as they're both more immediate and potentially higher. But as this has been an exercise of individual contributions, there may be some that flew below the radar coming into other areas of our idea space here. So that's why I wanted to try to get the dot voting in to try to capture some of that additional thinking about it. Yes.
So just to understand, should the priority include sort of tractability, like something that this group of people at this time can do, or is it just priority like?
I think that's an excellent question. I think it's appropriate, given we do want to have actionable steps coming out of this, that it's what can we do as a community? How can we potentially prioritize our work and activities?
This is Rob from Earthscope. When it comes to us potentially, kind of pitching in for each other to cover for mitigating loss or to rescue data and so forth, what do you think the level of risk would be for us to be overt about making a budget line item for that kind of support and requesting money for that kind of resiliency? Do you think we could approach a government agency or funder and say, we would like to put a line item for resilience of, community repositories in addition to ours? Do you think that's a safe thing?
That's an interesting question, and it probably depends on the specific funder and the flexibility or priorities of that funder. So it's not a very satisfying answer, but I think it is, because a strong case could be made in a data-centered proposal that having a coherent and effective data preservation and sharing plan is necessary. And it's how that plan articulates with the resources that you're asking for would be the strongest case to be made. But it depends on how you have to gauge the funding source to see how you might necessarily have to frame that. Yeah, Matt.
So I've been reflecting a little bit about Kelsey's question earlier about how do we convince repositories to say replicate other people's data more, and how hard that is to do at a large scale. And I think one strategy we could take to solve some of these problems of not having replicas where we need them is to try to get repositories to make bi-directional, just pairwise arrangements to exchange. So it's basically like part of their wind down plan to get two fairly similar repositories to say, I'll back up yours if you back up mine. And so it's a very, equitable relationship between them. But as a network, if we can do that systematically, then we might actually really improve the whole thing.
So yeah, there's, maybe some organizational or community practices that can emerge to help add resilience to our data.
So that makes me think of risk registers. So in managing an organization, often it's good to have a risk register where you identify all your risks, the likelihood of the risk, the impact of the risk, and your planned response if the risk comes into being. And as repositories, we should all have risk registers, or formally or informally. But it's making me think that as a community, we might be able to develop sort of a thing where we have some clarity of likelihood, impact, and how as a community we might respond to some of these, more broad-reaching risks. This, is sort of like the beginning of a risk register, except for the likelihood piece, which I think is a critical piece.
Yeah, and actually that may be the perfect opportunity to segue into where we potentially want to go from here as a community. Continuing this conversation, continuing this consideration of how we can identify and develop community plans around mitigation of these risks, especially after we've had more of an opportunity to characterize and understand them. So I guess my question would be, I like the idea of a risk registry that could be established and maintained within the community. Right. And with that as a starting point, we could certainly start by translating what we've captured here as a starting point for some of the content in that. it seems, I guess my, one question would be, is this, what we've done here, is this something that would logically potentially be brought to one of our existing collaboration areas? The Sustainable Data Management Group may be a logical target.
I just wanted to say that I think that the risks that are being done here are very general versions of what Joseph's already been doing with the trusted repository scorecards. And I think we have the same problem that was articulated in the session earlier, that it's one thing to identify the risks for the entire community and say, we all have this. It's another for a repository to stick their head up above the ground and say, hey, we're not like doing the best job at this yet, try to shoot us down, right? So nobody wants to put out a public risk registry where like they further endanger, their funding and stuff. So there's got to be some way to do it as a community that doesn't also increase risk for individual participants in the evaluation.
I didn't mean to imply that individual repositories should share their risk registries. That's an internal management document that, is a good thing to have. And a key thing with it is you have a responsible party and at least an initial approach to a response if the risk comes to be. What I say with the public thing would be is more of these generalized risks, and that would help with sort of, I think, what you were talking about earlier, Matt, where, okay, risk of massive data loss, develop partnerships. But then who? You're really starting to get down into, Data One provides this service. Who are the members within Data One that are going to actually do that? That sort of thing.
Yeah, I agree. I think that what we've started here and the development of a community risk registry can help provide a framework that can then feed into the individual organizational risk assessment activities that at least can facilitate getting the conversation started. And Joseph?
Okay, so we are at the end of the session, so I'll make it quick. If you're interested in the technical parts of doing, are you doing Metacat to Metacat or Data One generally? Well, anyway, replication between ERDAP, different RDMSs, please come at 4 p.m. We do have discussion topics. Since I have been voluntold by Mark to continue these conversations, there was a session idea that came in after the deadline, so I didn't get a chance to propose it, but having a conversation about developing standard MOUs for either partnerships between different repositories or among communities, starting to develop this language boilerplate contracts for what we can do to really engage with each other and make it very clear what we are asking each other to do in this moment, potentially in the future. As a part of developing the repository crisis scorecards, I do have a list of not quite risk registers, but a whole bunch of tools for looking at risk that other people have developed in the past. Again, since I've been voluntold to do this, the Sustainable Data Management Cluster meets on the first Monday of the month. Although it goes against my better instincts, we will hold a meeting and we will talk about both what kind of documents, contracts we can do, and are there other tools for managing risk, looking at risk, whether that's on the data set level, repository level, societal level, meteors falling out of the sky level. Yeah. Matt, online?
All good.
Okay. You're the interim executive director. Your word is law.
I'm afraid I might have been just by raising the specter of adding something else to the sustainable data management cluster. But yeah, I think this is a good opportunity to engage with the ongoing conversation that's going on in the collaboration area, and to bring folks in who see this is a valuable exercise to see how we can integrate it into our continued work as a community. As Joseph was saying, there is a session this afternoon. This is the link to the session in SCED. And it looks like there may be a slight extension to the hands-on activity, as we had an inquiry from a concurrent session that was going on at the exact same time as this one, where they're also going to be working on some data replication hands-on stuff. So Joseph, you weren't here while we were having that discussion, but it sounds like that there might be a slight extension of the diversity of activities going on in this afternoon session. So we invite you to join for some hands-on activities this afternoon. At just the point when you would otherwise contemplate taking a nap or something, this will be much more active. So unless there are any closing thoughts, I want to thank everybody for coming. I want to thank Matt and Dave for sharing the work that they've been doing in providing some grist for our mill and thinking about how we can start to identify and address these challenges that our data collections face. So thank you very much.